Operation IceBridge has now returned to the Pine Island Glacier not once but twice in 2012. And the year-old giant crack in the glacier, poised to create an iceberg the size of New York City, well, it's still there, and that iceberg has yet to break free. But the rift has grown longer, much wider, and spawned a secondary crack. Before we talk about when that mighty berg will be born, let's take a look at the IceBridge missions themselves. IceBridge's first return to the glacier was a high-altitude flight over the entire region, including the Thwaites, Smith, and Kohler glaciers. After this campaign is over, scientists will be able to compare this broad survey with previous year's measurements in order to better document the rapid and widespread changes in the region over time. For the second mission, NASA's DC-8 flew, as it does for most IceBridge flights, at 500 meters above the ice. And this mission was about creating a brand new set of data. The flight lines took the team over previously unmeasured tributaries of the glacier, and also surveyed the bedrock below them to provide a baseline for measuring change in the future. So while this focus on the Pine Island region, NASA Goddard calving specialist Kelly Brunt says the ice in the region is substantially thinning, and its flow is accelerating.
Ultimately, the change that we see in that whole region, not just Pine Island, but also its neighbor Thwaites Glacier, this change represents the largest input to sea level rise from an Antarctic source.
The rift has been an intriguing phenomenon to watch over this last year, but is it a really important event?
When we talk about Antarctica and we talk about the health and state of our ice sheets, we talk about mass balance. And what you have on one side of the mass balance equation is accumulation or snowfall coming in. And when we talk about balance, that has to be balanced by things coming out. And in Antarctica, that happens either through surface melt or basal melt, or the big number in Antarctica, which is calving. Calving accounts for 80% of that side of the equation. So when you see calving in Antarctica, even calving where we use small states or the island of Manhattan as a unit of measure, this is generally very normal. It's part of the process.
However, Brunt says once the glacier calves, the new calving front will be further upstream from any calving front we've seen in the last 40 years.
I've used the analogy of a fingernail to talk about calving. Generally, if your nail breaks in the white, it's normal and you don't worry about it. If your nail breaks below the white, you think about it, you remember it. If you lose your whole nail, that's a big deal. Much of the calving, the 80% of the net loss through calving, can be equated to losing the white part of your fingernail. Things that we saw in the early 2000s in the Antarctic Peninsula side, the Larsen A, the Larsen B, that's equivalent to losing your whole nail. What's going on in Pine Island is probably that intermediate, that we've broken our nail and it's below the white, and it's something to watch and something to monitor over time.
As a byproduct of the recent IceBridge flights, the team got some great views and measurements of the evolving crack, which has been filled in somewhat by blowing snow. The crack appears to have only a short distance to go before a new iceberg is born. It's still hard to know when that will happen, but conditions seem to be right.
Sea ice acts as a buttress or a dampener for sea swell that actually protects the front of these ice shelves or the front of these floating glaciers from calving. So the fact that there's no sea ice in front of Pine Island Glacier right now implies that it might be in a state that's sort of primed to calve.
After IceBridge heads back home from this campaign, its data will be used to monitor the state of Antarctic ice sheets, while satellites will continue to watch the rift in the Pine Island Glacier as the melt season continues.